Hello class. As a part of today's class on safe medication administration, we are going to discuss dose calculations. Unfortunately, medication errors do happen. While there are many checks in place, mistakes can still happen. When a medication is ordered, the doctor or practitioner places the order. In the inpatient setting, the pharmacist then looks at the medication order. They verify if it can be taken with other medications that the patient is already prescribed. Is it a duplicate? Should certain precautions take place? Is it the appropriate dose? Once the medication is verified, nursing must now do their part to check the medication. It is always okay to question if you think something is wrong. Do not assume that the doctor or the pharmacist are always correct. This may not be the case. This is how we advocate for our patients. Better to be safe and question than to give something and have something happen. Dosage calculations are used with all patients. It's especially important with the pediatric population. Even something as simple as Tylenol must be dosed according to the child's weight. This is the part of nursing where we see that dreaded algebra class from high school come back to help us. Let's say you have an adult patient who is being treated for a COPD exacerbation. The doctor has ordered for them to receive 40 milligrams of IV push methylprednisolone, also known as Salumedrol, every 8 hours. Now, when we go into the Pyxis to remove the medication, we see that it comes dosed 125 milligrams in a 2 ml vial. And now we must do some math. We need to figure out how many mLs to give the patient so that they receive 40 milligrams if 2 mLs equals 125 milligrams. So in this equation, 2 mLs times 40 milligrams, when we cross multiply, equals X mLs times 125 milligrams. We come up with 80 mLs per milligram equals 125x mLs per milligram. By dividing both sides by 125 mLs per milligram, we are able to solve for x. In this case, x equals 0.64. Therefore, we would give 0.64 mLs for the patient for them to receive the 40 milligrams of Salumedrol. Let's take a look at another example. Some medications, similar to that of pediatrics, requires that the dosage be based on the patient's size. With chemotherapy, the patient's dosage is based on their BSA. BSA is body surface area. This is the equation here for body surface area, which is the square root of the patient's weight and height in kilograms and centimeters multiplied together divided by 3,600. This is measured in meters squared. So for our patient, if the chemo order reads for them to receive 5-fluorouracil or 5-FU at 400 milligrams per meter squared, we must figure out the dosage, knowing that the patient's height is 5'11" and their weight is 211 pounds. The first thing we must do is convert the height and weight to kilograms and centimeters. If 1 inch equals 2.54 centimeters and 2.2 pounds equals 1 kilogram, then we can figure out centimeters and kilograms. So 5'11" is 71 inches times 2.54 equals 180.34 centimeters. Now for the weight, 211 pounds divided by 2.2 will give us the kilograms, which is 95.9 kilograms. Now we can figure out the BSA. Once we plug these numbers into our equation, we're able to see that the BSA equals the square root of 180.34 centimeters times 95.9 kilograms divided by 3,600. You can see the number 17,294.606 divided by 3,600. The square root of that is 2.19 meters squared, giving us the BSA for this patient. This is the number we'll need to plug in to figure out the dosage. If the order reads 400 milligrams per meter squared, then we take 400 and multiply it by the BSA of 2.19, and we're able to find that the patient will receive 876 milligrams of the 5-FU for their chemotherapy. The online quiz available at the end of the lecture will have a couple of simple questions about dosage calculations. In class next week, we'll work through sample problems together as a class, and this will allow you to learn from each other. Thank you very much. Feel free to contact me if you need to, and I look forward to seeing you in class. Have a great day.